Quick warning, not every popular car is a safe buy in 2026. Some fail because of design traits of you can spot, turbo sizing, thermal limits, transmission choice, weak brakes, or compromised electrical architecture. Today I will name 10 cars or types you should avoid right now, with the precise engineering reason for each and a practical alternative you can trust. No rumors, just engineering and owner's evidence. Let's go. I will name the car, give the engineering problem in one sentence, then explain why it matters in real ownership. If you want the source, I will pin everything in the description. Number 1. The Hyundai Creta. Multiple safety and components recalls were reported across recent model years. That's a red flag because repeated recall means a pattern in design and production that affects long-term ownership cost and downtime. If you are buying a used Creta, check recall completion records and insist on full service history before you sign. Why it matters? Recall usually target electronics, airbag units, or fuel systems. These are not cosmetic. Repaired once is fine. Repaired repeatedly signals systematic QA problems that increase your ownership risk. Number 2. The Seltos with the dry dual class, that is DCT. Dry DCTs can be crisp until they are used in heavy stop-start traffic. Owners report jadar, clutch wear, and heat sensitivity in the urban condition. Why it matters? A dry CTD lacks the oil bath cooling of a wet class. Repeated partial engagement in traffic generate heat that fatigue the clutch pack and control mechanics. Repairs can be costly. Number 3. Mahindra XUV 700. Several owner trades reportedly early reliability issue on high-end trims. While this SUV is impressive on paper, some owners have seen software glitches and mechanical faults early in ownership. Why it matters? Complex electronics and high feature content increase integration points. When wiring, ECU logic, or thermal calibration is inadequate, symptoms surface as warning lights, limp moods, and inconsistent behavior, leading to frequent dealer visits and downtime. Now, number 4. Tata Harrier. Several owners have reported brake feel and NVH concerns after high mileage. That points to either brake hardware sizing or chassis tuning not matching to actual car weights. Why it matters? Brakes need margin for heat dissipation. Undersized rotors or poor bed compounds will overheat with heavy mass and repeated hard braking, creating fade and warp disc, costly mechanical jobs later on. Number 5. Toyota Urban Cruiser Hyryder. A significant voluntary recall was issued recently for a fault combination meter affecting fuel gauge readout. Recalls like this can inconvenience owners and impact resale if not resolved. Now, why it matters? Even a non-safety recall, fuel gauge, erodes trust in manufacturing QA and increases the chance of other latent issues. Always verify recall status. Number 6. Some WB, Skoda DSG, particularly older dry clutch DQ200 and similar Europe-sourced DSGs. Known cases of early mechatronic failures and clutch wear under harsh driving conditions. Why it matters? These dry clutch DSGs offer high speed and efficiency, but their thermal and calibration margins can be tight. In stop-start or high-load environments, heat and micro-slip shorten lives and cause expensive repairs. Number 7. Any car that pairs a very small turbo engine with heavy body. This is poorly when used in traffic and short trips. I will name examples where owner complaints are frequent, but the engineering pattern is the key takeaway. Why it matters? Small turbos hit higher boost and higher EGTs to move more mass. Under low speed, high load conditions, they operate near thermal and mechanical limits. This accelerates turbo wear, oil degradation, and injector stress. Research warns that small displacement turbo engines can be less durable if consistently stressed. Number 8. Cars overloaded with screens, ADAS and connected features but built on older wiring electrical architecture. Symptom: random warning, battery drain, and software glitch. White matters. Adding multiple high current subsystem without upgrading alternator capacity, grounding and CN bus or busness causes intermittent faults. Electrical problems are time consuming and repeatedly hit the owner. Number 9. Certain low cost mass market models with poor crash test rating. For example, the Maruti Eco has historically scored poorly on adult occupant protection. Buying the cheapest vehicle with worse safety is a false economy. Why it matters? A low crash rating implies lack of structural integrity, fewer airbags, or weak restraint geometry. That increases risk in real collisions, a cost you may never afford. Number 10. Certain European luxury models like Bentley, BMW, Porsche, high-end Audi can be beautiful but come with predictable high maintenance and repair costs that can wipe out any performance premium if you are not prepared. Why it matters? Exotic engines, complex electronics, and premium parts mean high replacement costs and specialized labor. Studies rank this as the most expensive to maintain over 5 to 10 years. Factor this into your total cost of ownership. Now, quick recap. Avoid cars with repeated recalls, weak transmission choice for your city use, small turbos struggling in heavy bodies, under-spec brakes on heavy SUVs, and feature-heavy cars built on weak electrical architecture. If you are buying a specific model, do these 3 checks right now. Search recalls and owner forums for model year issues. VIN level recall completion is non-negotiable. Number 2. Match engine size to car weight. If a 1 liter or 1.2 liter turbo is asking to move a 1.5 to 1.7 tons regularly, assume higher long-term stress. Check transmission type versus your driving. Dry DCTs and certain DSGs can be problematic in stop-start traffic. If you want, drop a model you are considering in the comments. I will run a quick engineering check and tell you whether to buy, hold, or to avoid. Thank you.